AP Review, Chapter 20, Lesson 12. This will be the last lesson of the AP Review, and this will look at some electrochemistry free response questions. We're going to actually take a look at two of them. Okay, the first one involves a voltaic cell. So let's quickly read through this and see if we can answer some questions. The diagram on the right shows an electrochemical cell constructed with a lead electrode immersed in 100 ml of a 1 molar lead nitrate solution. Notice this is it right here on the left side. An electron made of some unknown metal immersed in 100 milliliters of X nitrate solution, which is on the right side here. A salt bridge containing potassium nitrate. Remember, salt bridge allows the two to be connected and allows the electrochemical cell to work for the electrons to flow. The electrodes are connected to an external circuit with an open switch. Here's the open switch. Then we also connect it through a voltmeter, so we can check at all times what the voltage is. We can take the switch off and check what the voltage is, and it'll run through the outside. And the voltmeter reads 0.47. So this is important. When the switch is closed, electrons flow through the switch from the PB electrode toward the X electrode. So electron pathway is here. This is our electrons. This will be important as we answer the questions. Let's see what we got. Write the equation for the half reaction that occurs at the anode in A. Now recall that the anode refers to the place where oxidation takes place. Oxidation happens. If you take a look, because we are producing electrons in the lead compartment, since electrons are leaving, we know that oxidation must occur here. That's really the only place the only way you can produce electrons. Remember, oxidation actually goes up in charge, which means you're producing electrons, and the electrons are essentially leaving. So this is the half reaction we want to write. Lead becoming lead 2+. And anytime you write an electrochemical half reaction or a full reaction, you have to consider your electrons. In the full reactions, these electrons cancel out, but in this half reaction, you definitely want to include the half reaction, the electrons, I'm sorry. The value of the standard potential is 0.47, which we were told. Determine the standard reduction potential for the half reaction that occurs in the cathode. Now for this, we can actually consult a reduction potentials table. So if we know that we have lead at the anode, and we know the overall voltage, which is 0.47, we can determine the voltage of the cathode. So looking at the reduction potentials table, you'll see that lead gives us a reduction potential. Here's lead. Lead gives us a negative 0.13, and let's plug that in and see if we can find the other one. So in this case, remember the total cell voltage is cathode minus anode. In this case, the total cell voltage is 0.47. Our anode, we said, was lead, and lead gave us negative 0.13. So our anode is negative 0.13, so we want to subtract the anode. We got the cathode minus the anode. Effectively, we're going to add it. So rearranging this equation, we got 0.47 minus 0.13, again minus because now I'm moving it to the left side, equals the cathode. So the cathode potential is actually 34 volts. This is the potential of the cathode. And now they're asking us to identify this metal that's producing this voltage, the half reaction that's producing this voltage. Do we have one that's 0.34? Aha, here it is. Notice we are dealing with none other than copper. So we have copper metal. This is a way you can actually determine an unknown is by checking the voltage that's produced. Now it says describe what happens to the mass of each electrode as the cell operates. Now as the cell operates, lead being oxidized is always being eaten away at, since we're losing lead and it's going into solution. Again, because this half reaction shows lead becoming lead 2+. So more and more lead increases in solution. So this is getting lighter. It's essentially dissolving. Whereas on the X electrode and the copper electrode, since electrons are coming in, the copper ions, and we know now that X is copper, the copper ions get attracted to those electrons coming in and begin plating. So this actually gets heavier. And that would be the answer. So cathode, you can say the anode mass decreases, cathode mass increases. And this is really a matter of analyzing the half cells. Okay, let's take a look at this second question. A fuel cell is an electrochemical cell that converts the chemical energy stored into fuel into electrical energy. A very famous fuel cell uses H2 as the fuel, and it can be constructed in the following two half reactions. So in both cases, notice water is involved, and one of the reasons is because water is used as a balancing agent in reactions. So we want to write the equation for the overall reaction. Now remember, if this reaction were to go on its own, the substance that has the higher reduction potential will get reduced. Because this is a higher number, this will get reduced. And since this is a low number, it has a lower reduction potential, because remember, these numbers come from the reduction potentials table. So we see here that this second reaction is going to get oxidized. Now being oxidized means we will have to flip this reaction because the electrons will have to be on the right side. In addition, notice that our electrons are not equal, so as we flip it, we'll have to double. So I'm going to go ahead and flip and double. Flip and multiply by 2. So we have 2 hydrogens on the left side plus 4 OH minus, becoming 4 water and 4 electrons. So this is now effectively flipped. Let's see if we can cancel everything out. So the 4 electrons should be cancelled out. And now let's go ahead and just rewrite the equation and see if it balances the overall reaction. So in addition to these electrons, actually, we see that water also cancels out. Notice 2 of these waters will cancel out with 2 of these waters. So we're down to 2 here. This is out. And hydroxide also gets canceled out. So these 4 hydroxides cancel out with these 4 hydroxides. And we actually end up with just some hydrogen and some water and some oxygen. Let's go ahead and try to rewrite it now. Rewriting this equation gets us, see if we can clean it up, that here's oxygen, O2, on the left side, plus 2 hydrogen, providing, notice we have 2 waters, and that's it. This makes sense. This is actually, if you take a look at it, this is the balanced equation for the production of water from hydrogen and oxygen. Simple as that. Next, they want us to calculate the standard potential for the cell. Well, we just do cathode minus anode. Let's do it out here. The cell potential is cathode minus anode. We said that our cathode, which gets reduced, is this guy, and our anode, which gets oxidized, is this guy. So we have 0.40 minus negative 0.83, which in effect is 0.40 plus 0.83, which is 1.23 volts. So this is the voltage you get whenever you react oxygen with hydrogen. And let's finish up with this one. Assume that 0.93 moles of hydrogen is consumed as the cell operates for 600 seconds. Calculate the number of moles of electrons that pass through the cell. Again, what we've got is we've got hydrogen reacting with oxygen to produce water. And then we have a balanced equation like so. So they're asking us for the moles of electrons that pass through the cell. Now when we cancel the electrons out, notice we had 4 electrons that are transferred between the two cells. You can also determine this just by looking at in counting. In fact, on the left side, if you take a look at hydrogen, we have 2 hydrogen. The hydrogen on the left side is by itself. It has a charge of 0. Here we have 4 hydrogen, so a total charge of +4. We could likewise look at the oxygen, which is 0 on the left side, and then we have 2 oxygens, which gives you -4, each being a -2. So we know that we transfer 4 electrons from the hydrogen to the oxygen. 4 electrons get transferred. And so we begin with 0.93 moles of hydrogen. This is really a stoichiometry problem. And based on the equation, 2 moles of hydrogen transfer 4 moles of electrons, which you're simply doubling. So you got yourself 1.86 moles of electrons. Not too bad. And then next we're asking about the current. Now the current is the rate of electron flow. So really what we want is we want how many electrons per second. And electrons are actually measured, the charge is measured in coulombs. And coulombs per second is amperage or current. There's an equation for this, so take a look at the equation sheet to see if you can find it. But the idea here is we want to know how many coulombs this is, and then we're going to simply divide by 600 seconds. So the relationship between coulombs and electrons is 96,500 coulombs, remember, is 1 mole of electrons. This is something called the Faraday constant. And because the property of electrons is its charge, or their charge, we can use the charge of the electrons to find out what the current is. So we've got these electrons, 1.86 moles. Let's go ahead and convert this to coulombs. So we know that a mole of electrons is 96,500 coulombs. So do this quick calculation, since this is free response and you do have access to a calculator. 1.86 multiplied by 96,500. So we end up with 179,490 coulombs. Amperage is defined as coulombs per second, so let's divide this by how many seconds we have, which is 600. Divide the two, and we end up with an amperage of 299 amperes, which is quite high. So using significant figures, we can say 299, or since we have 2 significant figures for the moles, we can say 300, or we can say 3.0 times 10 to the second amps. Now the AP exam will allow you one significant figure left or right. So if you say 299 amps, they'll allow it. If you say 300 amps, they'll also allow it. So this essentially concludes for us the electrochemistry review and all the rest of the review. Make sure that you definitely do the extra problems that were proposed and given to you in class. Well, first of all, go ahead and go through the rest of these practice problems, and I'll cycle through them for you and pause as needed. Here's number 9, number 10, 11, 12, and this is the multiple choice section. So make sure you practice problems, and then definitely look through all the 10 packets, the lectures that we gave you. It is extremely imperative that you study for the AP exam, otherwise the monster will simply pin you down to the ground and you'll just be screaming and wailing and waving your hands, and that will be the end of you. In other words, make sure you study, and we will see you later.